Table 5 of the National Electrical Code, or NEC, is applicable to solid conductors. The note in Annex C applies only to stranded conductors and doesn't exclude solid conductors from Table 5. Annex C is a non-mandatory appendix that provides additional information and guidance but does not modify or override the requirements of the code itself. Table 5 is a mandatory part of the NEC and provides the maximum fill for raceways based on the number and size of the conductors. You can use Table 5 to determine the maximum fill of a raceway with solid conductors because the table does not distinguish between stranded and solid conductors, and the maximum fill percentages provided apply to both types of conductors. The maximum fill percentages in Table 5 are based on the assumption that the conductors are installed in a raceway without any other cables or wires. If other cables or wires are present in the raceway, the maximum fill percentage may need to be reduced to ensure proper ventilation and heat dissipation. When considering conductor types and raceway fill, it's essential to understand the applicable sections of the National Electrical Code to ensure safe and compliant electrical installation. Firstly, focus on understanding the difference between mandatory rules and informative annexes. The NEC contains both mandatory rules, which are enforceable requirements, and informative annexes, which are not enforceable but provide additional guidance and background information. Always adhere to the mandatory rules for a safe and compliant installation. Secondly, recognize the scope of each table. NEC tables are specific to certain types of conductors and raceways. Make sure to use the correct table for the type of conductor and raceway you are working with. Using the wrong table could lead to an unsafe or non-compliant installation. Thirdly, account for derating factors. When multiple current-carrying conductors are installed in a raceway, the ampacity of each conductor must be derated to account for the increased heat generated by the conductors. This derating factor is specified in NEC Table 310.15 Current. Fourthly, ensure proper ventilation. Proper ventilation is essential to prevent overheating of conductors in a raceway. Make sure that the raceway is properly ventilated and that there is adequate space around the raceway to allow for heat dissipation. Fifthly, comply with local codes and regulations. In addition to the NEC, local codes and regulations may also apply to electrical installations. Make sure to comply with all applicable codes and regulations to ensure safe and compliant installation. When working with electrical systems, safety is paramount. Always follow safe work practices and wear appropriate personal protective equipment (PPE) such as gloves, safety glasses, and insulated tools. If you are not comfortable working with electrical systems, consult a qualified electrician. For specific conductor requirements, refer to the relevant NEC articles, such as Article 310 for conductors for general wiring. This article covers conductor types, sizes, insulation, ampacity, and other requirements. Pay close attention to the conductor's ampacity rating, which is the maximum current it can safely carry. The ampacity is affected by factors such as the conductor's size, insulation type, and the ambient temperature. Consult NEC Table 310.15b16 for the allowable ampacities of insulated conductors rated up to and including 2000 volts. In free air, based on ambient air temperatures of 30 degrees Celsius or 86 degrees Fahrenheit. For conductors installed in raceways or cables, the ampacity must be adjusted based on the number of current-carrying conductors in the raceway or cable. This adjustment is specified in NEC Table 310.15 When selecting a raceway, choose one that is suitable for the environment and the type of conductors being installed. Consider factors such as the material, size, and type of raceway. Common raceway types include electrical metallic tubing, or IMT, rigid metal conduit, or RMC, and flexible metal conduit, or FMC. Each raceway type has its own advantages and disadvantages, so choose the one that is most appropriate for the application. Ensure that the raceway is properly installed and supported. Use appropriate fittings and connectors to ensure a secure and watertight connection. Support the raceway at intervals specified in the NEC to prevent sagging or damage. Grounding is a critical aspect of electrical safety. Properly grounding the electrical system helps to protect against electrical shock and reduce the risk of fire. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and de-energizing the circuit. Grounding requirements are specified in NEC Article 250. Make sure to properly ground all metal enclosures, raceways, and equipment. Use appropriate grounding conductors and connectors. Bonding is another important aspect of electrical safety. Bonding involves connecting all metal parts of the electrical system together to create an electrically continuous path. Bonding helps to equalize the voltage potential between different metal parts, reducing the risk of electrical shock. Bonding requirements are specified in NEC Article 250. Make sure to properly bond all metal enclosures, raceways, and equipment. Use appropriate bonding conductors and connectors. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. An overload occurs when a circuit carries more current than it is designed to handle. A short circuit occurs when there is a direct connection between two ungrounded conductors or between an ungrounded conductor and a grounded conductor. Overcurrent protection devices are sized to protect the conductors in the circuit. The size of the overcurrent protection device must not exceed the ampacity of the conductor. Overcurrent protection requirements are specified in NEC Article 240. Select the appropriate overcurrent protection device for the circuit. Make sure that the overcurrent protection device is properly installed and maintained. Arc fault circuit interrupters, or RFCs, are designed to protect against arc faults. An arc fault is an unintentional electrical discharge that can occur in a circuit. Arc faults can generate high levels of heat and can cause fires. RFCs are designed to detect arc faults and interrupt the circuit, preventing a fire. RFC protection is required in many locations, such as bedrooms and living rooms. RFC requirements are specified in NEC Article 210.12. Install RFCs in all locations where they are required. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults. A ground fault occurs when there is an unintentional electrical connection between an ungrounded conductor and a grounded surface. Ground faults can cause electrical shock and can be fatal. GFCIs are designed to detect ground faults and interrupt the circuit, preventing electrical shock. GFCI protection is required in many locations, such as bathrooms, kitchens, and outdoor areas. GFCI requirements are specified in NEC Article 210.8. Install GFCIs in all locations where they are required. Surge protection devices, or SPDs, are designed to protect against voltage surges. A voltage surge is a temporary increase in voltage that can damage electrical equipment. Voltage surges can be caused by lightning strikes, power outages, and other events. SPD are designed to divert voltage surges away from electrical equipment, protecting it from damage. SPD requirements are specified in NEC Article 280. Install SPD to protect sensitive electrical equipment. Electrical inspections are conducted to ensure that electrical installations are safe and compliant with the NEC and local codes. Inspections are typically performed by qualified electrical inspectors. Schedule an electrical inspection after completing an electrical installation. Correct any deficiencies identified by the inspector. Proper labeling is essential for identifying electrical circuits and equipment. Labeling helps to prevent confusion and errors when working on electrical systems. Label all circuit breakers and fuses with the circuits they serve. Label all disconnect switches with the equipment they disconnect. Label all electrical panels with the voltage and amperage of the system. Electrical safety training is essential for anyone who works on or around electrical systems. Training helps to ensure that workers are aware of the hazards associated with electricity and that they know how to work safely. Attend electrical safety training courses. Follow safe work practices at all times. Regular maintenance is essential for ensuring the safe and reliable operation of electrical systems. Inspect electrical equipment regularly for signs of damage or wear. Repair or replace damaged equipment promptly. Clean electrical equipment to remove dust and debris. Test electrical systems to ensure they are functioning properly. Keep accurate records of all electrical work. This includes records of inspections, repairs, and maintenance. These records can be helpful for troubleshooting problems and for ensuring that the electrical system is properly maintained. Electrical codes and standards are constantly evolving. Stay up to date on the latest changes to the NEC and other relevant codes and standards. Attend continuing education courses. Read industry publications. Consult with qualified electrical professionals. Remember, electrical work can be dangerous. If you are not comfortable working with electrical systems, consult a qualified electrician. Electrical safety is everyone's responsibility. By following safe work practices and complying with electrical codes and standards, you can help to prevent electrical accidents and injuries. For additional guidance, refer to the NEC Handbook. The handbook provides explanations and examples of the NEC requirements. Consult with a qualified electrical professional for assistance with specific electrical projects. Always prioritize safety when working with electricity. Firstly, double-check the voltage before working on any electrical equipment. Secondly, always turn off the power before working on any electrical circuit. Thirdly, use properly insulated tools. Fourthly, never work on electrical equipment in wet conditions. Fifthly, if you are unsure about anything, ask a qualified electrician. Remember that electrical safety is not just a set of rules, it's a way of thinking. By making safety a priority in all aspects of your work, you can help to prevent accidents and injuries. When dealing with conductors and raceways, always ensure that the conductors are properly sized for the load. Overloaded conductors can overheat and cause fires. Use the NEC to determine the appropriate conductor size for the load. When pulling conductors into raceways, use a lubricant to reduce friction. This will make it easier to pull the conductors and will prevent damage to the insulation. Do not exceed the maximum fill capacity of the raceway. Overfilling a raceway can make it difficult to pull conductors and can reduce the ampacity of the conductors. When terminating conductors, use the proper connectors and tools. Improperly terminated conductors can loosen and cause arcing, which can lead to fires. When splicing conductors, use the proper splicing methods. Improperly spliced conductors can overheat and cause fires. When working with electrical equipment, always follow the manufacturer's instructions. The manufacturer's instructions will provide important information about the safe and proper operation of the equipment. When inspecting electrical equipment, look for signs of damage or wear. Damaged equipment should be repaired or replaced promptly. When testing electrical equipment, use the proper testing equipment. Using the wrong testing equipment can damage the equipment or give inaccurate results. When troubleshooting electrical problems, start by checking the simplest things first. Often, the problem is something simple, such as a tripped circuit breaker or a loose connection. When repairing electrical equipment, use only approved replacement parts. Using unapproved replacement parts can compromise the safety of the equipment. When working with electricity, always be aware of your surroundings. Avoid distractions and pay attention to what you are doing. When working with electricity, always be prepared for the unexpected. Have a plan in place for dealing with emergencies. Electrical safety is a continuous process. By staying informed and following safe work practices, you can help to prevent electrical accidents and injuries.